Concept 4, graphing direct variation. So when we're graphing a direct variation equation, we can approach it the same way as we do a normal equation. Okay? Any other equation, all we have to do is get our equation, okay? Make our table, find some points. X is 1, we have 3 times 1, 3. When x is 2, we have 3 times 2, or 6. And when x is 3, we have 3 times 3, or 9. Okay? And probably I should extend this out a little bit. When x is -1, we have 3 times -1, or -3, just to have one negative value in there. Okay? Oh, and my rule, 3x. So we've got our points. When you have a direct variation equation, you will always have a point at the origin. Okay, so I can make my point there. And then I've got a point at 1, 1, 2, 3, at 2, 1, 2, 3, 4, 5, 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 9. Okay, and -1, -1, 2, 3. Right, so I've got some points. Now I can make my line, make it green, and I'm just going to start here and line them up, something like that. Okay, so that is one way to do it. Okay, that's kind of the standard way. You often need to do that when you are working with non-direct variation equations. Okay, there is a shortcut that we can do because we're working with a direct variation equation. All right, and you can use it to a certain degree for other equations as well, but there's some other things that go into it. So we still start with a point at the origin. Okay, direct variation always has that point at the origin. Right, and then you've got your slope. Okay, so basically your slope is telling you that 2 is my y, 5 is my, should be equal, is my x, and I can also multiply both of those by any number. Right? So I could say that 2 times 2 is y, and 2 times 5 is x, or 3, or 5, or -1. Okay? It will always work out the same way, just like in here. Right? So what we're going to do, except this one had a denominator of 1, what we're going to do is we're basically going to start here, and we can just count. We can say, okay, I have 2 over 5. 2 is my rise, so I can come up 1, 2. 5 is my run, go over 1, 2, 3, 4, 5. Right? So 5, 2. I can do that again. 1, 2, 3, 4, 5 over, 2 up. I can do the same thing going this way. 2 down, 5 to the negative side. All right, and it becomes pretty easy to find your line and create it because you're not having to go through and calculate from the origin to find each of your points. You can just count from wherever, from any point on that line. Right? So if I create my line, and make it red. If I create my line, okay, and I go from, let's say I've got a point right here, okay, and who knows what it is. Maybe it's, well, it's going to be like, we'll say 1.5, and and 1 and, a third or something like that, okay? Or just a third, I guess. But either way, even from this point, I can go up to over 5, and I will still have another point on that graph, okay? So counting by your slope is a quick way to make new points on your line, right?